in case of the rat, needs species-specific correlation formulas to determine the heart rates and all. So that is the extrapolations. So there is the human ECG graph, and there is the rabbit ECG graph. That is the guinea pig ECG graph. That is the rat ECG graph, and that is the mouse ECG graph. Okay, and that is the site of the placement of electrodes. Okay, so what is the purpose for screen?
What are the differences denoting over here in
ST?
in case of the different species of animal?
Sir, actually, the ST segments, you see that in case of the human, that is the ST segment, ST interval, and in case of the rabbit, that is the ST segment, because the T waves comes just from the ending of the QRS complex. Okay, you see over here, this is the QRS, the ST interval. That is the ST interval. That is the ST interval. It's very less.
That means between S and T there is an isolated line.
Isolated line.
But in case of the smaller animal, you cannot find out that one. Okay?
Yes.
You can find out in case of the larger animal.
Larger animal. In case of the
And in case of like
Okay, rat is there and then mice, and if it is if we are taking the two smaller animal like zebrafish and all, so in case of that you will be not able to find out any kind of difference after the QR, and before completions of the S, the TF will start and it will finish. Okay, so that's why there is a graphical, when it will be in a graphical ECG graph or in that manner of presentation, so there you can find out the such differences.
Is it clear? Any question? Okay. So, in the conclusion, we can say that by interpreting the ECG data, we can easily evaluate any type of cardiac abnormalities like coronary artery disease, arterial fibrillations, arterial clutter. By interpreting the QT interval, RR interval, ST interval, we can easily identify any type of abnormalities or any kind of cardiac artifacts if influence on the heart of small rodents. We can easily evaluate by interpreting the ECG data. Okay, so in the P wave alterations, if we see that the P wave is elevated, then obviously any type of abnormality is present in the arteria. Right. In case of the QRS complex, any kind of abnormalities in the QRS complex is there. That indicates the abnormalities in the ventricular depolarization in case of the ventricular tachycardia. The RR interval is too short, correct? And there is a phenomena that is known as Dorset B pointus. Do you know what is this? Dorset B pointus. Do you know? In the Dorset B pointus, ventricular tachycardia takes place. Actually, QRS complex where ends, then further QRS is generated from there. Very rapidly, there is no, you cannot observe any ST segment. Very rapid QRS complex is generated. Okay, so that is our facilities in the cardiac research, in the domain of cardiac research, we have the BioPack NP36 free lead and 4 different channels. And by using the BioPack NP36, not only ECG, we can evaluate or we can take the data of electroencephalogram also and others. And that is the procedure. After the presentation, you all able to get the hands-on exposure on this BioPack NP36, and that is the procedure. First, place the animal, and after that, prepare the animal or the subject, not animal, because today we will perform the human as well as rat ECG by using BioPack NP36. Yesterday, you have done by using 6 lead ECG machine. Today we will perform by using 3 lead ECG machine. Okay? And prepare the subject and clean the electrode place. And we apply the gels. Okay? And after that, the lead placement. Left side, in the upper left side, we use the red colored electrode, and in the left leg we use black colored electrode.
Where it should be placed? From the diaphragm. From the diaphragm, so it will be in the upper side.
Upper side.
Where exactly it must be placed?
Actually, in the rib cage.
So you have to find out the beats actually.
Beats.
Sometimes,
where the beats are.
Sometimes in case of the animals, the heart is tilted towards the right also. And in case of the experimentations also, living experimentations or the research project and all, we found there is one exceptional case is also there, that heart is located towards the right side in case of the animals. So it happens generally. Okay. So while placing the leads, you have to be very careful. So you have to touch the thoracic area, and you can find out the beats. So where the beats are prominent, near to that you have to place the positive electrode, and opposite side of that you have to place the negative electrode. The negative electrodes denoted by the white color, whereas the positive electrodes denoted by the red wire. Okay, and the ground electrode function is, if you are seeing the ECG graph, there is no where there is no peak, that line is called as the isoelectric line. So the isoelectric line, there should not be any kind of artifacts in that. Artifacts means if there is any kind of artifacts or noise is there will be a zigzag linings will be there. Okay, so this ground electrode function is to minimize that noise. Okay, so that must be placed in the Gordian region, or we call as a foot in case of animal. Okay, so any side you can place, whether it is the right side, it is the left side or the right side, any side you can place. But generally we place onto the right side. The left side. Okay, and then the operations of the software is there when there is a proper placement of the electrodes, and these are the operations of the software. So one by one you have to opt the choice, and you have to go for the BioPack NP36 software setup. So in that way you can get the graph. So what we will do today is simultaneously we will place the animals as well as the human beings. So any of you can become a subject, and one side, in case of the channel 1, we will place the human subject, and another side the rodents will place. And you can have a live demonstrations, or you can have a live view that what is the difference between the ECG, running ECG, the live running current ECG, the difference in the various events or the intervals in the graph. So you can have that one. So before you conclude your presentations, I would like to ask that if you can give a nutshell of the difference between the rat and human ECG parameters, the wave parameters. that slide. So they can have those data actually. So while I demonstrate the ECG, they can get that whether the result is correlate with the standard results or not. Okay, so you can have those data, the data P wave, QRS complex, the dimensions and all, so that you can take down. So I'll give you another 5 minutes time for that, so you can take down these different waves durations. So you can take down those things. So it will be useful for you as a reference. So you do not have anything rather than mobile. You are in a workshop, just coming, just like you are coming in a theater. If you have a page, you can give to you. Where is that? That pad has been given to you in that folder. Kit. Any of you get one pad? And what is that? Okay.
diagnose it, take some time, some milliseconds, and then again the next value. That's why here our rate is not detectable in the time. Not detectable. If you zoom it out, that's a
So any questions from the audience? Any questions? Okay. Thank you. Thank you everyone.
Nutshell differences you have taken in the tabular form. Have you all taken that one?
Either you have noted down, just take the difference.
Because those intervals only we will be discussing, okay, live in the live demonstration.
But can you go to that slide where you have the difference between the preclinical and the clinical time frame difference?
শুধু মোবাইল হাতে আর কিছু নেই, ফোন নেই, কিছু নেই, প্যাড নেই, হাত নেই, আঙুল নেই, কিছু নেই।
একদম এর মাঝখানে দিয়ে